Hello everyone, we are group 17. Today we are going to talk about the application of drones in wildlife conservation. Our team members are Weiji, Janet, and Yuhang. There are three main purposes to use drone in wildlife conservation. First, determine the distribution and the density of animal species. Second, to prevent poachers hunting. Third, mapping the land cover and the land cover change. Why using drones? The most common method before is using manned aircraft, satellite, kite, and balloons. Comparing to drones, use of satellite and manned aircraft are too expensive. Use of kite and balloons require suitable weather and may take few days to complete one task. What type of drones to use? The most popular craft types include multi-rotor, fixed wings, and a vertical takeoff and landing craft. You might be familiar with multi-rotor and fixed wing craft. VTO aircraft is the combination of multi-rotor and fixed wing craft. Each type of drones has its pros and cons. Multi-rotor and VTO aircraft don't need large space to take off. Multi-rotor craft can carry heavier payload. Fixed-wing craft can has larger flight time. It is important to use the appropriate type based on the requirement and the operating conditions. Sensors are the main component for data collection. Different sensors can be used in different situations. For many animal surface, a simple RGB photo camera can do the job. But for nocturnal animal, a thermal sensor should be used. And cover classification might be possible with RGB images, but they could not be more accurate. Modified RGB camera or multispectral camera are often applied for the collection of such data. A key aspect to collect data is whether the sensor and the flying height combination will yield images of sufficient resolution. It is important to calculate the ground resolution, often called GSD, which is the distance between the center of two adjacent pixels in an image. Next, Janet will talk about the surveillance.
So one of the most pressing conservation challenges in recent decades is the illegal trade and trafficking of wildlife and associated products, as well as unregulated fishing. Therefore, it is important to collect accurate and precise data on animal distribution and density so that population sizes can be estimated. Here in the table are the workflow considerations. There are many steps to consider here, from whether the animal species of interest can be detected, whether the site can be reached, weather conditions, the flying regulations, to potential social issues, logistical issues such as having electricity to charge batteries for cameras and ground control stations, and others. As mentioned above, poaching is one of the largest threats to wildlife, especially to some highly valuable animals such as elephants and tigers. The areas in which such species need to be protected are often large, while at the same time the resources are often limited. Drones can be used to facilitate anti-poaching efforts by finding wildlife that might be at risk of being poached and detecting poachers themselves. However, even with the help of drones, in some cases, compared to the large size of some of these areas, for example, the Kruger National Park that covers 19,480 kilometers square. The area that can be patrolled during one drone flight is extremely small. A database analytical model have been developed to predict where a crime might occur. For example, a study shows that 89% of poaching events occurred in areas that are within 4 kilometers of a road. The efficiency of a single drone flight can be optimized by considering this model and assumptions. Another common application for drones is mapping. A common approach to achieving this is to take a series of overlapping aerial photographs as the drone flies over a landscape. Drones can also be used to monitor the health of forests and other natural habitats. Some data collected can be further analyzed to give us an indication of underlying causes of declines, such as disease and water stress. Drones can also be used to produce digital surface models. One of the most important use of DSM is to get an estimate of biomass, which is a key indicator of the carbon stock contained within the forest. Therefore, in general, drones can be used as a tool for wildlife conservation. However, there are a few challenges regarding technical, ethics, and regulation. The biggest technical challenge is the limited flight time. And another challenge is that some drones require large landing space, and the pilot will need to be sufficiently skilled to land the drones. The next challenge is that the real-time communication of data between drones and the ground operator to enable rapid response to developing situation. Other than technical challenges, ethics should also be considered to avoid some unknown impact to wildlife and the privacy rights of people who are under surveillance during drone missions. Regulations for the operation of drones also differ between countries.
First, let me introduce a way to do 3D reconstruction, which is SFM. It stands for Structure from Motion. It is an algorithm to rebuild 3D from huge amount of images with overlapping area. Unlike traditional way, you don't need many features on the images for which the 3D location is known. And you also don't need camera details such as focal length, number of pixels. Geotagged images and pose data of the drone are not necessary, but helpful to improve the quality and speed up the process. The right side image illustrates how to create 3D from images. For part A, images are often captured at slightly different angles by changing the pose of the drone, and the reference points that occur on 2 or more photographs are marked. Then the images can be merged together. Part B shows the top view and the 3D thereafter SFM algorithm. SFM creates high-quality map with more details for monitoring ecosystem. From the map, the biologists can analyze the biodiversity of the area and its growth for conservation. Nowadays, the most common power source is rechargeable Li-ion or LiPo battery. Solar cell can also be its power source, but too expensive. An example is the Antarctica Solar. It's a 6.9 kilogram drone that completes an 81-hour continuous flight. The new power source is under development, such as hydrogen fuel cell. Autonomous system would be effective for drone to complete tasks. For now, most drones are a bit capable of it because we can preset the speed, altitude, and some waypoints. At last, the conservation drone is important for biologists to check ecosystems, and the number of use is increasing. And here's our reference. Thank you for watching.